Hi, my name's Simon Stringfield. I'm ECTI 451 student and my project is effective deterrence of fauna using programmable sonic alerts. So what is it? It's a programmable device that emits an array of frequencies and it's controlled using a microcontroller using a pulse width modulation to emit certain frequencies. It's used to deter animals from approaching a moving vehicle on the roads and it's also used to alert animals to the presence of a moving vehicle. Obviously to keep them away from moving vehicles, to stop them getting run over. Why does this need to be done? Animal vehicle collisions account for 5.5% of the human road toll as of 2008 and they cause significant death of human life, human injuries, animal injuries and also property damage, mainly to cars and other infrastructure such as fences if a car may collide with them. The aim of the project is to develop a device that effectively deters animals from moving vehicles and it's to be able to just mount onto any normal vehicle such as a truck, four-wheel drive or even just a normal car. The device must be weatherproof and also able to stand up to debris and other conditions such as dust, heat and rain obviously if it's to be mounted on the exterior of a vehicle. Some devices exist already, such as the RooGuard. These emit ultrasonic frequencies to shoo away kangaroos. The idea behind this is that the ultrasonic frequencies can't be heard by humans, so the occupants of the vehicle, and they're also quite humane to kangaroos and to other animals as well in that they don't cause harm or distress or any noticeable level of harm or distress to the animal. The ultrasonic frequencies have been proved not to be that effective. Kangaroos have an optimal hearing range of about 2 to 3.5 kilohertz and up to the ultrasonic frequencies they don't hear them that well. I'm focusing mainly on kangaroos to start with because they account for 44% of animal vehicle collisions in Australia and then other animals will be focused on later on such as wombats, wallabies, koalas, those sorts of animals. Probably a better sound to be used or signal to be used for such a device would be a macropodoid foot thump. A macropodoid is just includes this family of animals including wallabies, kangaroos, and it's a sound made by them striking their hind feet on the ground powerfully. It's quite a loud sound. Research suggests that it may be used to warn predators that a kangaroo knows of the predator's presence, or may indeed just be used to warn other kangaroos or other animal species of the presence of a predator. So the sound would be better to be used because it holds more social significance for these animals rather than just an ultrasonic frequency. The Doppler effect is something that I've also had to consider for this device since it will be mounted on a moving vehicle. So the Doppler effect is the apparent frequency shift of a signal heard by a stationary observer when a sound source is moving away from or towards them. This may affect the frequencies heard by animals in the device since the motor vehicles are often moving quite quickly, so some sort of frequency shift within the pulse width modulation may have to be accounted for. Directional testing was conducted using an Arduino and a speaker. This was done with a 3D printed cone that was placed around the speaker and a sound level was used to test if the front signal was amplified by the cone and also if the two side signals were decreased in level. It was actually found that the cone did increase the front level of the signal, but it also increased the side ones, probably due to some unaccounted for reverberation in the plastic cone. Some future work will be different frequencies of other animals. Field testing of certain signals to ensure that whatever signal is used does work, and this will be done with similar methods that I've researched. Thank you for watching.
Bye.